Fahrenheit.
Fahrenheit is a temperature scale based on one proposed in 1724 by the physicist Daniel Gabriel Fahrenheit, after whom the scale is named. On Fahrenheit's original scale, the lower defining point was the lowest temperature to which he could reproducibly cool brine, while the highest was that of the average human core body temperature. There exist several stories on the exact original definition of his scale. However, some of the specifics have been presumed lost or exaggerated with time. The scale is now usually defined by two fixed points. The temperature at which water freezes into ice is defined as 32 degrees, and the boiling point of water is defined to be 212 degrees, a 180-degree separation, as defined at sea level and standard atmospheric pressure. By the end of the 20th century, most countries used the Celsius scale rather than the Fahrenheit scale. Fahrenheit remains the official scale for the following countries: the Bahamas, Belize, the Cayman Islands, Palau, and the United States and Associated Territories, Puerto Rico, Guam and the U.S. Virgin Islands. Canada retains it as a supplementary scale that can be used alongside Celsius. The Rankine temperature scale was based upon the Fahrenheit temperature scale, with its zero representing absolute zero instead.
Definition and conversions.
On the Fahrenheit scale, the freezing point of water is 32 degrees Fahrenheit, DEGF, and the boiling point 212 DEGF, at standard atmospheric pressure. This puts the boiling and freezing points of water exactly 180 degrees apart. Therefore, a degree on the Fahrenheit scale is 1/180th of the interval between the freezing point and the boiling point. On the Celsius scale, the freezing and boiling points of water are about 100 degrees apart. A temperature interval of 1 DEGF is equal to an interval of -9 degrees Celsius. The Fahrenheit and Celsius scales intersect at -40 deg, -40 DEGF and -40 DEGC represent the same temperature. Absolute zero is -273.15 DEGC or -459.67 DEGF. The Rankine temperature scale uses degree intervals of the same size as those of the Fahrenheit scale, except that absolute zero is 0R, the same way that the Kelvin temperature scale matches the Celsius scale, except that absolute zero is 0K. The Fahrenheit scale uses the symbol deg to denote a point on the temperature scale, as does Celsius, and the letter F to indicate the use of the Fahrenheit scale. For example, gallium melts at 85.5763 DEGF, as well as to denote a difference between temperatures or an uncertainty in temperature. For example, the output of the heat exchanger experiences an increase of 72 DEGF and our standard uncertainty is ±5 DEGF. A rule of thumb for conversion between degrees Celsius and degrees Fahrenheit is as follows. Fahrenheit to Celsius, subtract 32 and have the resulting number. Celsius to Fahrenheit, double the number and add 32. This formula gives an answer correct to within 1 DEGC for 0 DEGF. -17.8 DEGC, 50 DEGF, 10 DEGC, and within 4 DEGC for 100 DEGF, 37.8 DEGC. For an accurate conversion, the following formulas can be applied. Fahrenheit to Celsius, DEGF, 32/1.8 equals DEGC. Celsius to Fahrenheit, DEGC x 1.8 plus 32 equals DEGF.
History.
Fahrenheit proposed his temperature scale in 1724, basing it on 3 reference points of temperature. In his initial scale, which is not the final Fahrenheit scale, the 0 point is determined by placing the thermometer in brine. He used a mixture of ice, water, and ammonium chloride, a salt, at a 1:1 ratio. This is a frigorific mixture which stabilizes its temperature automatically. That stable temperature was defined as 0 DEGF, -17.78 DEGC. The second point, at 32 degrees, was a mixture of ice and water without the ammonium chloride at a 1:1 ratio. The third point, 96 degrees, was approximately the human body temperature, then called blood heat. According to a story and trivia question in Germany, Fahrenheit actually chose the lowest air temperature measured in his hometown Danzig in winter 1708/09 as 0 DEGF, and only later had the need to be able to make this value reproducible using brine. This is one explanation given why 0 DEGF is minus 17.78 DEGC, but the ammonium chloride cooling temperature actually is minus 3 DEGC, whereas that of NaCl is minus 21.1 DEGC. The other explanation is that he did not have a good enough brine solution to obtain the eutectic equilibrium exactly, that is, he might have had a mixture of salts, or it had not fully dissolved. In any case, the definition of the Fahrenheit scale has changed since. According to a letter Fahrenheit wrote to his friend Hermann Boerhaave, his scale was built on the work of Ole Romer, whom he had met earlier. In Romer's scale, brine freezes at 0, water freezes and melts at 7.5 degrees, body temperature is 22.5, and water boils at 60 degrees. Fahrenheit multiplied each value by 4 in order to eliminate fractions and increase the granularity of the scale. He then recalibrated his scale using the melting point of ice and normal human body temperature, which were at 30 and 90 degrees. He adjusted the scale so that the melting point of ice would be 32 degrees and body temperature 96 degrees, so that 64 intervals would separate the two, allowing him to mark degree lines on his instruments by simply bisecting the interval 6 times, since 64 is 2 to the 6th power. Fahrenheit observed that water boils at about 212 degrees using the scale. Later, other scientists decided to redefine the scale slightly to make the freezing point exactly 32 DEGF, and the boiling point exactly 212 DEGF or 180 degrees higher. It is for this reason that normal human body temperature is approximately 98 deg, oral temperature, on the revised scale, whereas it was 90 deg on Fahrenheit's multiplication of Romer, and 96 deg on his original scale.
Usage.
The Fahrenheit scale was the primary temperature standard for climatic, industrial and medical purposes in English-speaking countries until the 1960s. In the late 1960s and 1970s, the Celsius scale replaced Fahrenheit in almost all of those countries, with the notable exception of the United States, typically during their metrication process. Fahrenheit is used in the Bahamas, Belize, the Cayman Islands, Palau, and the United States and associated territories, Puerto Rico, Guam and the U.S. Virgin Islands, for everyday applications. For example, U.S. weather forecasts, food cooking, and freezing temperatures are typically given in degrees Fahrenheit. Scientists, such as meteorologists, use Celsius or Kelvin in all countries. In some nations, both measures are quoted. Early in the 20th century, Halsey and Dale suggested that the resistance to the use of centigrade, now Celsius, system in the U.S. included the larger size of each degree Celsius and the lower 0 point in the Fahrenheit system. Canada has passed legislation favoring the international system of units, while also maintaining legal definitions for traditional Canadian imperial units. Canadian weather reports are conveyed using degrees Celsius with occasional reference to Fahrenheit, especially for cross-border broadcasts. Virtually all Canadian ovens make legal use of the Fahrenheit scale. Thermometers, both digital and analog, sold in Canada usually employ both the Celsius and Fahrenheit scales. Also, in some instances, swimming pool temperature or cooking temperatures in Quebec, for example, temperatures are still expressed in Fahrenheit. Within the European Union, it is mandatory to use kelvins or degrees Celsius when quoting temperature for economic, public health, public safety and administrative purposes, though degrees Fahrenheit may be used alongside degrees Celsius as a supplementary unit. For example, the laundry symbols used in the United Kingdom follow the recommendations of ISO 3758/2005 showing the temperature of the washing machine water in degrees Celsius only. The equivalent label in North America uses 1 to 6 dots to denote temperature with an optional temperature in degrees Celsius. Within the unregulated sector, such as journalism, the use of Fahrenheit in the United Kingdom follows no fixed pattern, with degrees Fahrenheit often appearing alongside degrees Celsius. The Daily Mail, on its daily weather page, quotes Celsius first, followed by Fahrenheit in brackets. The Daily Telegraph does not mention Fahrenheit on its daily weather page, while the Times also has an all-metric daily weather page but has a Celsius to Fahrenheit conversion table. When publishing news stories, Much of the UK press adopted a convention of using degrees Celsius in headlines relating to low temperatures and Fahrenheit for high temperatures. In February 2006, the writer of an article in The Times suggested that the rationale was one of emphasis. -6 DEGC sounds colder than 21 DEGF and 94 DEGF sounds more impressive than 34 DEGC.
Unicode representation of symbol.
The Fahrenheit symbol has its own Unicode character, U+2109. This is a compatibility character encoded for round-trip compatibility with legacy CJK encodings, which included it to conform to layout in square ideographic character cells, and vertical layout. Use of compatibility characters is discouraged by the Unicode Consortium. The ordinary degree sign, U+OOBO, followed by the Latin letter F, DEGF is thus the preferred way of recording the symbol for degree Fahrenheit.